Hello everybody, this is Mr. Bowman. Today we're going to be looking at the Alex topic, informal argument for the formula of the area of a circle. So we're not going to do any official proofs or anything. This is going to be informal, just kind of helping you see what's going on. So this one's interesting because we have this circle that's currently split into 4 parts. If instead of arranging them where our radiuses are touching like this, so the curves are continuous, we're going to kind of reverse them so that they are set up like this and kind of see what happens. So right now we have 4 pieces. If I drag this over, I get 6 pieces, then 8 pieces, 10 pieces, all the way up to 12 pieces. So notice what's going on here. When we have less pieces, we get more of these curves, big kind of bouncy curves, and this is very sloped. When I come over here, this is evening out. It's still bumpy, okay? But it's evening out, so it's less bumpy, and our curve here is getting steeper. It's getting more and more vertical. All right, so it's sort of looking like more and more like a parallelogram. So we get these kind of parallel top and bottoms, and our sloped sides here. So for the answer, or sorry, for the other parts, we're supposed to assume that the radius is 4 centimeters. So if I look at the base, so I'm going to choose the bottom base here of the parallelogram, how is it related to the circumference of the circle? So the circumference goes all the way around here, right? If this is just the outsides of the green parts, so I'm losing the pink ones, which is about, well, actually it's exactly half, right? Because I cut it in circle here. So my circumference, we know that's that's just 2 pi r. So if my r is 4, then I end up with 8 pi, and it does say use the pi symbol, don't give decimals. So you don't want to do 8 times pi, just write 8 pi. So the length of the base of the parallelogram, notice it is half of this, so it would actually just be 4 pi. Okay. Now the height, that's over here. This is getting closer and closer to vertical, so the height itself is actually going to be equal to the radius eventually. So the height, in this case, is going to be 4. Notice it's not quite now, it's a little sloped, but if we kept breaking them into more and more and more pieces, it's getting closer and closer. So eventually it's going to be equal to the radius once it gets vertical. So use the parts above to find the area of our parallelogram. So parallelograms work very similarly to rectangles or anything like that. So we want our base times our height. So in this case, our base is 4 pi. Our height is 4, so when I multiply those together, I get 16 pi. Cool. All right. So the circle is rearranged so that, so the area of the circle should be equal to the area of the parallelogram because it's the same pieces, just arranged in different setups. Using this fact, choose the equation that gives the area of the circle in terms of r. So I know there's going to be a pi, and there's pi's everywhere. Well, yeah, that's fine. So how does 16 relate to 4? Okay. So there's a couple ones that if I tried this out, seems like they'd be close, but the only one that works completely is this one right here. We have pi times r squared because it's r times 4 squared, which is 16. If I tried this one, it'd be 4 times 2, which is 8. That won't work. This one has a 4, which seems promising, but it's squared too, so 4 times 4 is 16, times 4 again would be 64, not 16. This would just be 4 pi. That's not going to do it together. This one's going to be even worse. So we got 16 times 8, which is going to be, what's that, 128? 128 pi. So the only one, if I plugged in my radius of 4 here, would give me this is that one right there. Okay. So it's a little weird, but that's kind of how they set up and help you find that area equals pi r squared formula.